Hello and welcome to today's episode of Kitchen Physics. I'm your host, Amanda. I'm a CPA by day and a foodie by night, and here I am doing fascinating physics in my kitchen. Let's get started. Today's physics experiment involves a secret of the universe, namely that the net force on an object is equal to its change in momentum over time. This secret of the universe should enable us to calculate the net forces on an object by looking at the changes in its motion. In this experiment, we calculated the mass of a black hole by looking at the changes in the motion of a star that is affected by the gravitational force of the black hole. I calculated the mass of my black hole to be 2.38 times 10 to the 31st kilograms. The force of gravity of the black hole on the star is calculated by taking the constant g times the mass of the black hole times the mass of the star divided by the magnitude of the distance squared times the direction of the distance. Or to state the formula, the force of gravity of the black hole on the star equals g times m1 times m2 divided by the magnitude of r squared times r hat, where g is a constant 6.7 times 10 to the minus 11 newtons times meters squared divided by kilograms squared. This formula can be rearranged algebraically to find the mass of the black hole as follows. The mass of the black hole equals the magnitude of the net force times the magnitude of r squared divided by g times the mass of the star. I wrote a computer model based on a data file of the observed motions of the star. First, I set up the initial conditions of the system by entering the mass of the star as given in the WebAssign problem and the delta t of 1 Earth day. I imported the data file into the problem here. I calculated the velocity vectors and the momentum vectors for each step of the data file. I then calculated the changes in momentum, calculated dp over dt, and set dp over dt equal to Fnet. I then calculated the parallel component of the net force and subtracted the parallel component from the total net force to calculate the perpendicular component of the net force. I also programmed the computer to place arrows on its display so that the net forces could be visualized. The green line is the curving track of the object. The yellow arrow is the total net force, the blue arrow is the perpendicular component of the net force, and the black arrow is the parallel component of the net force. The computer calculated the net force, which I would need to calculate the mass of the black hole. I then used a spreadsheet program to calculate the mass of the black hole. I calculated the position vector between the star and the black hole at the final data point. I used that information to calculate the magnitude of that vector and then squared that magnitude. I multiplied the magnitude squared times the Fnet calculated by the computer program and then divided that by the constant g and by the mass of the star. What does it mean? The secret of the universe is that Fnet perpendicular, Fnet parallel, and Fnet are the same as dp dt perpendicular, dp dt parallel, and dp dt because the net force is the cause of the change in the motion. What if? I believe that the setup of the problem and the physics formulas mean that there is only one mass that could possibly be found for the black hole. And since I got that little green check mark on WebAssign at long last, I'm feeling like the secrets of the universe are all here in my kitchen. As for black holes in the kitchen, what about those leftovers in the back of your freezer? You know you don't know what that stuff is or where it came from. Keep a Sharpie in your kitchen drawer and write yourself a note next time you freeze something. Thanks for watching, and I'll see you next time on Kitchen Physics.